Today in this video, we're going to go over how this reaction occurs and what the possible products are, as well as finding the major product, or the product that is most favorable. NaOH, also heat. And this reaction is added slowly and makes this final product. So the first line of business, this is what's created from these reagents. So the first step is identifying the alpha carbon that has possible hydrogens. Based off of these two, there is no hydrogens next to the corresponding carbon. However, there is 2 hydrogens located directly to the carbon that is attached to the oxygen, which is essentially just aldehyde. These are both aldehydes. So this will be essentially attacking that. That's the first line. Going forward, so these nearby hydrogens will be deprotonated with OH, which will then go towards that carbon. This will, of course, create H2O as a product, as well as 2 electrons. Now, based off of just intuition, you can kind of guess where those 2 carbons are going to go. It's going to be attacking this carbon with the oxygen attached. So just for short, this aromatic ring stands for pH. So I'm just going to write pH so this will attach to that carbon, holding the oxygen, and this double bond will create a pair of electrons to the oxygen. Which makes the, oxygen, of course, negative because the amount of electrons it has. This, of course, stands for the aromatic ring. There is a hydrogen there. Original oxygen. And then the 2 carbons from before that is attached. Now going forward, this oxygen needs a proton, so it's going to grab it from water. This will make OH, alcohol, not to forget there is a hydrogen there. So that is the product that we get from that. After oxygen grabs a hydrogen, grabs a proton, this is what's left. We can't forget that there is a hydrogen here. That's very important in the mechanism. And OH will, of course, grab that. Now, if those lone pairs of electrons will form a double bond, kicking this alcohol out, generating the final product. Everything matches. I know rotational wise it's a little bit different than shown, but everything is kind of almost rotated and flipped. So we have a bond there going to the double bond. This 1,2 carbon is right here. That double bond is right there. And then the last bond to the aromatic ring. So this is the final product, and this is butanol, enol plus enolate, benzyl hydride. And now there is another possible product that could be produced. I'll draw it out for you. And this is butanol self-condensation. Because the reason why this can only self-condensate, because this reagent doesn't have any corresponding hydrogens on the beta carbon. So this can't self, and then this can't be attacked as well. So these are the only two possible products that could be produced. The reason why this would be more favored is it's conjugated and stabilized. It's more electrophilic, and it also can form an enolate. The reason why this reaction is added slowly is to avoid self-condensation to form a beta unsaturated aldehyde. So this is the final product that is produced in this reaction.